Dear student, now after a few days, let's see the solubility remaining topic. That's a solubility remaining topic. So in generally, the last video, the solubility, the solid in the liquid solution. So now the gas in liquid solution. For that solution, here gas as a solute and liquid as a solvent. For this solution, how it's affecting for that solubility. Okay, so in generally, the solute of gas plus that's a solvent as a liquid gives solute plus solvent gives what? That's a solution. Okay, very good. Solution plus that's a heat. For that reason, in this reaction or exothermic in generally whenever a chemical reaction during for that the thermal energy are removed from the system, so that is for the exothermic reaction. Okay, so in see, this beaker is containing the solvent. For this solvent, it's dissolved. Actually, the solute is dissolved into the solvent. For actually, the solute as a gas. We know that the system as a open. If consider as a system as a open, the gases intermolecular distance as a highest. So for that, the randomness increases for gaseous. So the system if you opened, the gases cannot be dissolved into the liquid of solvent. For that reason, we consider as a closed system. We can add it to the solute into the system. Actually, the system is a closed system. Now the partial pressure increases at the top of this solvent. Okay, so now the partial pressure increases, actually its a solubility also increases. Okay, there is a partial pressure increases the solubility. Actually, that is meaning external pressure. External pressure increases, the solubility also increases. And another one case, in generally, the system, if considers exothermic, that thermal energy are removed from that system. So actual the temperature is decreases for this system. The solute are more easily dissolved dissolved. So here the solubility water, the solubility as increases. So in generally, the pressure is directly proportional of solubility, and temperature is inversely proportional of the solubility. Okay, so for that pressure relation solubility, Henry's law, we will see we will see in this video. Okay, so now the nature of the gases and solvent. The first category, previous solution like that. First category as nature of, that is a nature of the solute and solvent. So now the gases are more liquefiable or more soluble. There is a liquefiable liquefiable gas or more soluble. Liquefiable gas or more soluble, and also that the highest critical temperature containing gases are more soluble. So the critical temperature as highest or more soluble in the solution. Okay, so now for example, the carbon dioxide and ammonia, they have highest critical temperature. For that reason, its a solubility as a greater compared to the H2 and helium gases. Okay, so wherever the gases highest critical temperature, that is a more soluble. in the solvent. And the final category, there is a greater solubility of gases in a solvent is due to the chemical similarity between the gas and solvent. Okay, so there is a chemical similarity. This one of the major important because of last solution we studied the polar like that, and or non-polar are soluble compared to that polar non-polar, or there is a non-polar polar. For that any one is changed for that kind of solution cannot be dissolved. Okay, so the next category, there is a effect of temperature. Okay, so that is a effect of temperature. For that temperature, actually there is a inversely proportional of the solubility, inversely proportional of solubility, because of the temperature or reduces the solubility or increases. Okay, in the case of temperature or inversely proportional of the solubility, inversely proportional of the solubility for that gas liquid solution. Then third effect, there is a pressure. Okay, there's a pressure. We know that the pressure as a directly proportional of the solubility. For this mostly there is a external pressure. In generally, the pressure effect or representing the Henry's law. So this is the most important. Henry's law is the most important. Okay, the solubility of gas in any solvent increases with increase of temperature. Okay, so the temperature increase of pressure, the solubility of gas in any solvent increases with increase of pressure. So there is a solubility, there is a increases and the pressure also increases. Okay, so now the Henry was the first to be give a quantitative relation between the pressure and solubility. There is a quantitative relation means the graph have given there is a solubility and the pressure. Okay, so the Henry was first to give a quantitative relation between the pressure and solubility of gas is known as the Henry's law. For example, see this curve as helium gas. There is a helium gas, and also there is a this is a nitrogen gas, and this is representing for that there is a O2 gas. So in generally the solubility increases with increase of partial pressure. Okay, or there is a pressure increases, actually it's a solubility also increases. Okay, so now the formula they have given, there is a pressure is directly proportional of the mole fraction. Okay, so now we can add to the proportionality constant, the pressure is equal to kHx. Okay, so now this kH is nothing but there is a Henry's law constant. Henry's law constant. Okay, so the kH as a Henry's law constant. And another one graph, see the partial pressure of HCl in tar and mole fraction of HCl, the partial pressure and mole fraction we given the graph. There is nothing but there's a partial pressure of HCl, and there is here the mole fraction of HCl. For that it is a very straight line, that is mean that there is a positive slope we can obtain. Okay, so the positive slope we can obtain. So in generally the kH Henry's law constant as directly proportional of the temperature and inversely proportional of the solubility. We know that already the temperature are inversely proportional of solubility, as well as the Temperature is directly proportional of kH. So now we see that some examples. In the case of nitrogen and oxygen, hydrogen, carbon dioxide, methane, so like that, the Henry's law constant as well as the temperature, there is a completely, there is a varied. Okay, so then the limitation are given in the case of Henry's law constant. So that is for first limitation. So that is nothing but limitation first case. That is our moderate pressure they have maintained moderate pressure. Okay, then second category moderate temperature. And a third category when gases are less soluble. Third one, there is a when gases are less soluble. And fourth category, the gases do not react with the solvent. That is a must be important. Okay, because the if the solute or reactant with reacted with the solvent, that is a mostly affecting. So there is a third category, there is a gases do not react with the solvent. Okay, the gases do not react with the solvent. Okay, then when gases neither dissociate nor associate in the solvent. Okay, that is also important. The gases or dissociate or associate in the solvent. Okay, okay. So the finally the application of Henry's law that is given in the NCERT book. For example, to increase of solubility in carbon dioxide in soft drink and soda water bottles are sealed under high pressure, and Cuba reverse microscope with high concentration of dissolved gases while breathing at a high pressure under water. So like that, they have given in the application point of view. There is 4 point in the NCERT book. Okay, okay. Mostly the videos are uploaded based on that NCERT textbook. For most that is useful for the NEET and JEE exams. Okay, if you like my video, you can subscribe and share your friends. Thank you to all.